We're not going to talk about that.
Hi, Kobe.
Hello.
How are you?
I'm good.
Yeah. How is school so far?
It's been all right.
So that's good. Hi, Jen.
Hello.
So we're gonna wait for the other students to join.
Hello, everyone.
Hi, Gail.
How you doing?
Good.
Awesome. Let me change my background real quick, and then we can go ahead and get started. Here we go. All right.
Let's,
so,
Gail, let's give it a couple of more minutes.
okay.
Some students haven't joined yet.
Okay. Okay, great. Yeah. So just let me know when to get started.
Sure.
All right. Also, it would be nice if everybody can have their cameras on, if possible. If not, then it's okay. You know, we're just having fun here. But yeah, it would be nice if I can just meet all of the students.
Gail.
Yes.
Jen is the Python programming instructor.
Okay. Awesome.
Hi, nice to meet you.
Nice to meet you. Yeah, I went into the Google Classroom and I was trying to access the files, but I didn't have permission. So I requested the permission to like the first one.
Yeah, so what I'm gonna do is because you can't access it unless you have a blended learning and study center
Okay.
email account.
Okay.
So maybe what I'll do is I'll create an account for you.
Okay.
And then you'll be able to access it.
Okay. Yeah, I mean, if anything, to be honest with you, if I'm with Jane, then I can just coordinate with her. So that might not necessarily be necessary. We'll just have to have like a meeting where we kind of, you can say merge the learning concepts, right? I think that's really what I just wanted to know, because Python, you can use Python for almost anything nowadays. And we just have to make sure that what is being taught essentially is kind of, it's in sync to what they need to code their stuff. So that's it. Which I guess I'll just have maybe Jane's email and then we'll meet like someday at a certain point in time to, just so that she can show me the different modules and stuff like that. So.
Yeah, I can send you a chat with my email right now.
Okay, great. Got it.
So Jen, I made you the host. So in case I get cut off.
Okay, perfect. Yeah, thank you.
Hi there.
Hello.
Is the coding link,
Say
No,
that.
Sam.
Say that one more time, Samuel.
is the coding link sent for today?
No, you're in the right place for right now.
Okay.
So there's 3 students now. Honestly, the first, since this is gonna be recorded, I think that, I mean, we can start. Coyote, I think, the first day to be honest with you, what I had in mind was to also go over what is robotics in order for them to kind of get an understanding. So it might not be as, you can say, intense, or at least what I had. I don't know what Jane had to present. But it's mostly a presentation for all of the students to kind of have an understanding of robotics. And for those that didn't make it, they can rewatch it so long as they can, watch it before the next meeting and then show up on time for the next meeting.
Okay, no problem.
Okay.
Go ahead.
And so it's a total of 5 students, right? Or 4?
Supposed to be 5 students showing up today, or 6,
Okay.
I should say, actually.
Okay, so yeah, maybe they'll show up midway, but I just wanted to make sure to go ahead and get started. So yeah, Samuel, Kobe, Joseph, again, it'll be really nice if you guys can have your cameras. At least the first day, I'd like to know who I'm talking to and then get acquainted, because we're gonna be learning together for the next few months. So if you can turn on your cameras, if you can't, it'll be nice, but come on, guys, don't be shy, even if the lighting is bad. All right, so hello, Kobe. All right, so I'm gonna go ahead and get started. Let me turn this into presentation mode. All right, so I wanna go ahead and first, so I'm actually gonna give you guys a very similar presentation than I gave to the interns. So I'm actually gonna call this ARC first meeting, right? So aerospace robotics competition first meeting, right? And so first meeting, okay, just call it first, right? So my name is Gael Guterra, and I'm the outreach project manager for NSBE, Aerospace Special Interest Group. And NSBE is National Society of Black Engineers, right? And the Aerospace Special Interest Group is just what it is. It's people that are interested in aerospace projects just like you guys, right? And I'm giving you guys the same exact presentation that I gave to the interns meeting, obviously removing a few things, just because I believe that robotics is the future of, you can say, the world, on how the world is going to operate. And I 100% believe that, especially if you guys are already coding at such a young age, then you guys are part of the future of how robotics and aerial robotics, which I'm gonna go and introduce to you guys later, right? And so, first question for everybody, right? So what is a robot? And Jane and Coyote, you can also chime in. So what do you guys think is a robot? Kobe, you're muted.
Like an automated machine.
Okay. Joseph, what's a robot, Joseph?
A machine that sometimes takes care of some stuff.
All right. That's nice and broad, right? Jane, a shot. I don't know your background, but maybe you already know, but it's okay.
Maybe just like anything that can use a computer brain to do human activity.
Awesome. Awesome. And so just, I think everybody was actually spot on, right? But I especially liked Joseph's response, right? So a machine that does some stuff, right? Because that's a broad, right? That's a broad definition. And honestly, that's what robotics is, right? And with the automation part that Kobe mentioned, right? So there's many different kind of robots. There's humanoid robots, which basically look like humans. And they're made to emulate humans, just like the Valkyrie one that you see on the right. Almost like Buzz Lightyear, as you guys seen in your cartoons, right? And to also help people, for example, in the medical field, right? For example, you have this robot right in the middle. It's for dentistry work, right? And as Jane implied, robots are essentially designed to replicate, you can say, activities that humans are able to do. And and the thinking part that she mentioned is really the automation part that Kobe expressed, right? So a robot has to have a programmable components in order to make those decisions, and it can also self-improve. And the key word here is programmable, right? And so how do you program machines is through the languages, computer languages, just like you'll be learning with Python, right? And also robots essentially interact with the world around us, or the world or the environment around it, right? So a quick focus on, I'm not gonna dive super deep into it. This is Project Valkyrie, which is a humanoid robot that won NASA a robotics competition. I think now it's actually R5. This is a humanoid robot that is 6'2", and it's meant to be sent into outer space to essentially help humans explore environments that we don't want to send actual physical humans, right? And when we do want to start colonizing other planets, right? Another humanoid robot that was most recently shown to the world by Tesla is this one called the Tesla bot. And so this one is a little bit shorter at 5'8", 48 pounds, so it's really skinny. And so I believe this one their intentions is to help humans in their daily tasks, maybe be like some kind of like maid or something, or some kind of assistant. So yeah, robots come in all shapes of form. One thing I forgot to mention was also this Roomba. It's a small robot that was made to essentially be a vacuum cleaner. And it is a robot because it essentially sends a bunch of lasers around it in order to sense and in order to know how far the walls are, and essentially maneuver around your room or even stairs or stuff like that. So it's a robot in that sense, right? And so what we'll be focused on for the next few months is aerial robots, right? So you guys have seen drones around your, maybe when you go, I don't know if you guys have bought drones, but you go to Best Buy, you go to Walmart, you see a bunch of drones, right? However, some of these drones are robots and some of them are not, right? And just so you can kind of make a quick, intuitively, so the really, really expensive ones are categorized as robots, and the really cheap ones are not robots, right? And so how can you tell that, right? So the more, the cheaper ones, there are what we categorize as controlled by RC or radio control, right? And so these kinds of drones, although they may have a camera, they're not able to think, right? As we mentioned earlier, right? And they don't necessarily have an autonomous components, neither can they be programmed with Python, right? However, the ones such as like Mavic 2, Mavic Air, they are actually used for, like, for example, like inspecting like houses, inspecting like terrains. And if like the pilot does like sends in the wrong command and the drone is really close to a wall and might crash into the wall, the robot or the drone in this case is able to just stop, right? Because it's able to perceive, and the word for it is obstacle avoidance and an object avoidance, right? And so it has those components, right? And so a very famous robot that was sent to another planet is called the, what was it called? The Ingenuity, the Mars Ingenuity helicopter. And so this one was essentially a demo flight to demonstrate that we can fly helicopters on another planet, and we can fly robots on another planet, on planets other than just Earth, right? And there's many examples other than the Ingenuity Mars helicopter. And so this is another picture of it. So it weighs a mere 4 pounds. So it's really light and actually, but extremely powerful, right? So I don't even think most computers now weigh under 4 pounds, right? I mean, this is quite a feat, right? And this is something that is programmed using very similar methodologies than what you'll be learning here. So next slide is typically these aerial vehicles and these robots, they gain their autonomy through ROS. We will most likely not be touching ROS, or which is Robot Operating System in this case, but I wanted to mention this to you all so that you are all aware of it. So most of these aerial vehicles, or even these humanoid bots, they gain their autonomy through a meta operating system, which is called the Robot Operating System, right? And so I wanted to highlight one particular aerial robot that I like, which is called the Zipline Drone. And so, or there's Zips in short. And so these drones are essentially used to deliver medical supplies, and they're actually operational in Rwanda and in Ghana, right? And so this is just to show you how important robotics and aerial robots will play to the future of the world, right? Why do they choose to operate in Rwanda and in Ghana? Because of regulatory problems with the FAA, and it's just easier to start such a project in countries where regulations are not that big, right? And so, and I'm gonna show you guys a quick exercise, Python exercise that involves these Zipline drones. And so typically, I'm not gonna go through this. So, okay, let me go through this real quick so that you're aware, right? Because we might touch on these subjects when we get closer to ARC. Is aerial robots, they have several tasks. So there's modeling, state estimation and perception, and then flight controls, and then motion planning, right? So the modeling part is really just, you can say the flight dynamics. So a bunch of equations that govern, or you can say rules that tell the robots essentially what they're meant to do. And then there's state estimation and perception, which is essentially how robots learn how to interact with the world around them. And then there's the flight controls, which is, you can call it in short, just flight control laws. And then there's motion planning, basically telling the drone what path is it going to take, right? And some of these tasks are also, can also be applied to, you can say, some of these other robots, but these are, especially with state estimation and the modeling, some of the laws are different, right? And another thing is also self-driving cars can be categorized as robots, right? Because again, they don't use that much human interaction, right? And so this is kind of a diagram of what I just showed you guys. And so last quick slide is that, so again, for you guys, and the reason why we're all here is that in January, we're all as a team gonna enter into what is called the Aerial Robotics Competition by AIAA. And so the ARC essentially is a competition where you can be competing with other high school students to design a aerial robot that is tasked for a specific mission. And so the mission for this year will be search and rescue. And we will be competing in this competition with a tele drone, which you'll be able to program fully in Python. So, and so, yeah, so be excited. You'll be learning quite a lot of really interesting things. I think it's interesting and really cool and really fun. And yeah, so you have already the drone. I think Dr. Adebowale already has the drone with him. And yeah, so we'll have quite a lot of fun. I have a drone of my own here. I have a co-drone, and I also have a DJI Tele drone, just because again, it's really cool for me to play around with these things. There's just a lot of fun to be learning such powerful things, as I mentioned to you, with, you can say, and while having fun. So yeah, so that's kind of what I had for right now. So I want to take a pause for any questions before we go into the Python exercise that I had planned.
I have a question.
Yes. Go ahead.
What Python platform will we use?
Excuse me? Say that again?
What Python platform will we use?
So actually Python, you can use really any platform. I think the word that you're looking for is IDE, or Integrated Development Environment. And maybe Jane can answer to what she had planned, because I'm flexible with any.
Yeah, so me and the boys have been working with Spider a little bit, but I don't know if you want to move to Colab or something like that, where we can have a more collaborative environment.
Okay, so I think we can have that conversation separately. But thank you for asking that question, Samuel, and that's something that we can definitely think about. As far as why we would use Colab is maybe for like presentation, but for the actual implementation, it will have to be an IDE. I had PyCharm in mind, that's just because that's what I've used, but anything works for me. It's just PyCharm. There's also PyCharm Edu, which is actually something that I found recently, which is actually good for educators to also send in assignments to students. So, and it's something I have played around with. I don't necessarily, I can't remember exactly how it works. It's just something that I sought to explore, but it won't take me long to understand how PyCharm Edu works, but also Spider, I'm open to Spider. But yeah, thank you for asking that question, Samuel. And I think that we will, we'll for sure know that by next week's meeting. So or in the meeting in the future. So
Okay, thank you.
no problem. So any other question?
Yeah, will we learn like general codes to get the drone in the air? Like,
Yeah, yeah, you definitely will. It's gonna be a lot of fun. I'm already having fun, as you can tell. I wouldn't be doing anything else on my Friday nights, you know, to be honest with you, than maybe playing with drones. So, all right. So, it's gonna be a ridiculous amount of fun. So, any other questions? I just wanted to kind of get that out of the way. Okay. So I'm gonna go ahead and share my screen again. So this is how PyCharm looks like. And I have 4 different, I'm gonna call them, I mean, we call them bugged sim zips. And so, so Zipline, the company that I mentioned earlier, they have a internship position that is essentially a robotics position. And so the way that they screen their interviews, the people that they want to interview, is through building an autopilot system for you can say a drone delivery kind of system that was based out of Pygame. Now, I won't necessarily have you guys do that. So I have and I have obtained the rights to do this. So there's 4 different versions of, you can say, the simulator that have bugs. And so I wanted to, you know, just to gauge your level of Python, essentially, you know, by having you guys help me bug or debug through this code, right? And so can everybody look at my screen?
yes,
Okay. So so I'm gonna attempt at running the first one, right? So you call, I like working with terminals, right? Even whatever idea I use, I just like, I don't know why, but it's just a pet peeve of mine. So I'm gonna call I'm gonna run the bug sim zip, the first one, by in this way. So Python bug sim zip 1.py. And so I have my first error, right? And so can anybody, so this is the code, right? And so can anybody help me debug through this? So it's telling us at line 146, right? So I'm gonna go through the code and then line 146. Let's go, it is right here. So can you help me find out what the error is?
Sam and Joe, I know you guys know this one. Think about the syntax that we talked about and what that DEF means, what that signals to you that we're doing.
it's defining.
Right, so we have a function, right? But is there, can you think of, and then look at where that little caret is pointing exactly in the line. Can you remember what we usually are supposed to have there when we're defining a function?
Those 2 dots.
All right, fantastic. We go, okay? I'm gonna save it and then run this again. Oh, look at this. We have our simulator. You see it, right? So I can control it with my keyboard. So I'm flying my zip, right? And then when I see like a delivery spot, I can press the tab. I think it's kind of slow, but let me see. Yeah, it's okay. So here we go. We debugged our first one, right? So, okay, looks like you guys know some Python. Here we go. So let's do the second one. Okay. This one doesn't run. Let me see. It just popped up just once. Let me see. Actually, I think there was one more bug in this first one. I think it's the keyboard control because I wasn't able to deliver. But anyways, let's go with the third one because the second one just popped up and left. Okay, here we go. Here's the third one, right? So def, okay. So this one is quite simple as well. So we go to 102, 102. Okay. So who can help me debug this? It's very similar to the previous one.
I think Joe can do this one.
Excuse me?
I think Joe can do this one.
Joseph, can you help us?
I think you need a colon.
Okay. So do I just put the colon like this?
No, you have to backspace the. Yeah.
Okay,
and then-
awesome. Here we go. Okay, so yeah, I think there's more bugs here, but I definitely think that you guys are definitely prepared. So let's try the fourth one. And those, I think, oh wow, super easy. Yeah, I think you guys are definitely, if you guys know what a function definition is, and you know that, you have a decent understanding of the syntax, then I think we'll be fine. Yeah, I think we'll be fine. So yeah, that's it. I just wanted to kind of gauge your level through these really simple tasks. My intentions was to not necessarily have you guys have like, a Python coding interview. I just wanted to know if you guys, have some of these basics at least. So yeah, that's really all I had. And I'm quite content. So maybe if Jane had something else. I had also a quick video, if we did have time, to show essentially like a safety presentation for the telodrone, because the same telodrone is the same drone that we used at MIT Beaver Works Summer Institute for the summer camp. So yeah, as far as my gauging where your Python knowledge is, then I think we're good. Maybe if there's any other questions or comments. Okay, so how long are the Friday evening sessions meant to be?
I believe we have this Zoom room booked until 5:15, but usually we only are not, sorry, I'm in a different time zone, until 8:15, but usually we only go about 45 minutes.
Okay, so we got about 15 minutes left. Okay, so I'm gonna do a quick safety presentation in regards to your telodrome, so that, again, we can maybe start playing around with it as soon as we can. And then over the course of our lectures, then I'm gonna introduce slowly but surely not only Python concepts, but also specifically how drones are programmed. But the safety is obviously a high concern. And so this is just the same video that we played for our camp this past year. So let me see.
Just a quick comment on that. Do we want to maybe start charging the batteries now before we do the safety?
So I want everybody to show me your box.
Cool.
You should have one of these.
So the telodrome comes in one of those boxes. And again, Dr. Coyote can...
So there was a miscommunication with what you guys got. So I need you guys to charge it. 3 batteries. Oh, and put all 3 batteries. AG.
Let's speed this up a bit.
I got the same thing.
And every time you work.
We'll be here for you.
Yeah,
Okay.
I'm here for you.
Okay. So welcome to UAV safety. this is gonna be a very short one. There's a bunch of stuff we can talk about. We're gonna talk about a couple of things in general, so you guys know. But since the Telo drone, it's very safe, it's very small, I'm just gonna discuss a couple of things related to this one with you guys, okay? So we talk about this. We already tell you to open it. Make sure that you have the batteries visible. Don't leave them alone.
Yeah, so unfortunately, we didn't have the bandwidth to send you guys face shields, but please be careful when playing with the Telo and make sure that all of the propellers are attached, because when it starts going, some of those propellers can actually fly off. So
just make sure. I'm going to show you why you should never leave them alone. And every time you work with the drone, that you're close, that your face is close to the propellers and things like that, you have to wear your face shield. One of the big things that we need to break from with MATLAB and all stuff, okay? So next. Know before you fly. This is a website from AMA, FAA, and AUVSE, which are the main entities that actually discuss things about drones. We're gonna give you that link so you guys can look at it, and we're gonna watch a little video. Like I said, this is gonna be you guys ready?
Drones are a great way to introduce children to aviation and spark innovation. Although drones are fun to fly, that toy you're considering for purchase is actually classified as an aircraft by the FAA. And there are important safety rules and tips you'll need to follow. First, any drone flown strictly for recreational purposes that weighs more than about half a pound must be registered with the FAA. You can do this through the FAA Drone Zone. Anyone aged 13 and up can register. An adult must register for anyone under 13. Registration costs $5 and is good for 3 years. Then, mark the drone on the outside with the registration number. After you are registered, make sure you know the basics of flying your drone. Remember to always keep your drone in sight, never interfere with other aircraft, and keep it at or below 400 feet. Since airspace can be confusing, we have a free app called Before You Fly that helps you understand what airspace you're in. If you want to fly in controlled airspace, you'll need authorization from the FAA before you fly. You can learn more on our website, along with videos and safety materials. Welcome to the world of aviation. Fly safe and have fun.
That's what we wait. And the drones and airplanes and everything that you do not have the places of the institution, the university, you are not required to have neither a license nor an FAA registration.
So just in short, our Telo drone does not weigh 250 grams. It weighs 87 grams. And so you don't actually have to register your Telo drone. But is this, again, is something good for you guys to know. Obviously, you know, if you want to maybe play with a drone that's a little bit heavier, and maybe if you guys just fly through the content that we have, maybe we can build our own drone for the ARC. Yeah, so, but that's just something for us to know, is that if the drone weighs over 250 grams, then we'll have to get it registered by the FAA.
Have to make sure of that. But since the Telo weighs only 80 grams, you do not have to register.
Oh,
you do
look
not
at
have
that.
to get a license. You do not have.
Look at that. Joseph is already showing off the drone. Awesome.
have to do anything, so you can just fly it indoors. So this is your Tello. And the fun part about it is that you don't need anything for it, just all your eagerness and curiosity to do stuff with it. So like I said, including the battery and the propellers, weighs 80 grams. All the measurements that you see here are in millimeters, because in the aerospace, you have to learn how to use metrics. The propellers are 3 inches. We talked about propellers before. And it has a rangefinder, barometer, LED, vision system, which is the cameras that you see at the bottom. And it has an antenna, which is 2.4 gigahertz Wi-Fi. And the video that you record on it is 720p. And it has a micro USB charging port. Now, these numbers you have to remember. Flight performance. The flight maximum distance is 100 meters, okay? That is from your phone and unobstructed. That means if you fly outside, you can fly only 100 meters before you lose connection. And if it's in a windy day, you can lose it.
Okay, so this is something important for you guys to know, is that so the drone, you can actually fly the drone using the Tello app, right? So you can, right? However, that won't necessarily mean that we are programming the drone to do some of the autonomous tasks that I just mentioned, right? So it would just be just regular, playing with your Tello drone using your phone. And so the maximum distance will be 100 meters. However, in terms of the words that I want to use the big aerospace type words. So your phone is your ground control station. If you do end up playing with the drone with just your phone is your ground control station, right? And then the max flight distance will be 100 meters, right? However, when we start actually coding the drone, your computer becomes your ground control station, right? The same exact words that are used so you have your ground control station at the airport, and there's actually a certain distance in between the airport or the ground control station to the planes that are actually flying, right? And so this is a distance, but it's a radius year round. So when you fly your drone, make sure that you have a decent amount of space. If you do intend on it being bigger than 100 meters, make sure that you don't send your drone on a mission that's past 100 meters, right? And so also your flight time is 13 meters, which is why there are 2 batteries in that drone. Make sure that both of your batteries are actually charged, right? Or at least you have one that is constantly charging. And also the max height is 30 meters above the ground control station. Okay.
The maximum flight time with a fully charged battery is 13 minutes. That can vary depending on the program that you guys are going to be doing with Geo and with Gaia. It can be from 7 to 13 minutes. So that's not set in stone. It depends on all the stuff that the drone is going to do. But in general, 13 minutes. And your maximum flight height is 30 meters. Okay. So 100 meters straight line and 30 minutes high, that's the maximum that you can fly this drone. Okay. Make sure to remember that, because if you lose it when you put a face up, all the feet of the tail are the antennas. That's where you have a good connection. The light in front of the aircraft status indicator, when you turn it on, that's going to turn on. Green is because it's good. Red is running out of battery. You have the camera, you have the power button. Again, the antennas. It has 2 cameras what are using facing down that are using for vision position system that determines the altitude that you have. And with those cameras not determine the altitude because they're too far away from the rock, then you have inside a barometer that actually tells you how high you are. The micro USB port can just charge the battery, and you have the propeller guards. So when you grab it like this, that's the way it looks like. Okay. All good? Any questions?
I have a question.
Go ahead.
Why does it have a camera? Why does the Telo drone have a camera?
You said why does the Telo drone have a camera? So earlier I mentioned about robotics, right? What makes a robot essentially different than a simple toy? So that goes back to that same question, right? So can you, first of all, can you answer my question first? And then, and it's based on some of the discussions we had at the very beginning. What makes a robot different than not a robot? What makes a robot, right? So I'm gonna answer that, right? So it's called automation, right? So the drone has certain autonomous features, and it has it that the end goal of a robot is to get it to try, at least to try, to almost make decisions, right? And make decisions on their own, right? And so, for example, you as a human being, right? Why do you have eyes, right? Is in order to see, like, so for example, if you're walking somewhere and you see an obstacle, right? You don't realize it because it's subconscious. Or for example, you see like a door, you say, okay, well, there's a door in front of me. I have to open the door, right? And so why does the drone have a camera? In scientific term, they call it, so it's able to perceive the space around it, right? And so the camera is essentially a sensor in order to basically give information to the drone, telling it where it is, telling the drone where it is essentially located, right? That's essentially why, in short, that's why it has a camera. And yeah, that's why it has a camera. And so the thing is, some of those smaller drones that are just RC drones, they do have a camera. However, those cameras won't be able to help the program. However, in the way that we're going to be using it, we will be using the camera for what is called computer vision, right? Computer vision based automation. So that's why it has a camera. It's in order for the drone to know how to make decisions and to be as autonomous as it can. So. Okay, so any other questions?
Well,
and go ahead.
will we be able to see through the camera?
Yeah, you'll be able to see with the camera. You'll be able to see through the camera using a module. It's called OpenCV, and that is called Python OpenCV, which is short for Python Open Computer Vision. And so that's the Python library that we're gonna use in order to see through the camera.
Oh.
Yeah. Okay. So any other questions? Okay, great.
No? Okay. Checklists are important. Go through your checklist. One is a real one. The propellers are made of plastic,
so
they can break if it crashed.
So if you can get safety goggles, I would get them. Just because, again, we don't want you guys to lose an eye or eyes, both of your eyes at such a young age, if one of the propellers end up flying off. However, if you don't have goggles, then, again, make sure there's an adult with you that can make sure that the propellers are fastened. But I definitely think that, especially for as we get near to the competition, and as we use our drone more and more, there might be wear and tear to our brushless, to our motors, which might end up causing maybe expected to happen. So I think as we get closer to the competition, then we might have to put in a budget to get you guys goggles, at least, if not face shields and goggles.
And you can just fly into your face, which is not fun. You can get cut. You can get cut in your hands and everything. In this case, like we said, the Telo is safe. you already tested. He was grabbing it and he touched one port. You have smaller control, or your cell phone
I have a
is
question.
fully charged. You have to ensure.
Okay. Yes,
Are the safety goggles glass or plastic?
they're plastic.
Okay.
All right. So I'm gonna fly through this really quickly. So yeah, so you remember, so just make sure that your remote control device, whether it be your computer or your phone, is fully charged. Make sure that the battery on the drone is mounted firmly. Ensure that the propellers and propeller guards are in good condition. Also ensure that there's nothing obstructing the motors and that the motors are functioning normally. And so check that the camera lens and the vision positioning system sensor are clean. So complete the additional pre-flight checklist in the so yeah, I'm gonna give this checklist to everyone. Ensure that, so we're gonna go through what an IMU is in another presentation, but essentially an IMU is the inertial measurement unit. And just in short, that's what the drone uses in order to know essentially if it's yawing, pitching, or rolling, which is essentially, we're gonna go through all of that in another presentation. Okay, so yeah, I'm gonna make sure to give you guys this checklist next time. So one thing is, again, avoid flying around too many people, just because, again, if let's say you lose connection to your ground control system, and you might end up hurting someone while the drone is flying. And the first time that we're gonna actually take off, you'll see how powerful the drone is. Even though it's small, it's small and mighty. So don't fly near high power voltage power lines, just because there's something called electromagnetic, there might be something called electromagnetic interference, which essentially it might break the communication between your computer and your drone, which might cause the drone to do something unexpected, or even maybe even blow up. So there's just a few things. Check the weather conditions. Yeah, so not too much wind. So the thing is, with the drone being so light, it might not be good at flying in windy conditions, so try to avoid that. I would say the best place to fly your drone is your garage. Yeah, so, or a room that doesn't have that much AC in it. So let's see here. The battery is really powerful. It's a lithium-ion battery. So just be really, really careful. Don't charge it for too long, more than the estimated charge time. So one thing about the Teledrone that might not necessarily be good is that, again, the flight time, the battery life is 13 minutes, while it takes 2 hours to charge the actual batteries, right? So make sure that the batteries are charged, but don't leave them for too long over the 2-hour limit, right? And yeah, so also your battery, keep it in a very safe space, just because these blow up, right? And I'm gonna show you guys what a lithium-ion battery can do. And don't poke at it either, so.
Good. We are outside, of course, and I'm wondering how much bending about and prodding one of these will take.
Yeah, you don't want that to happen to you, right? Don't poke at it. They're really powerful. It can cause an explosion, maybe set off a fire.
Have.
Yeah, so this.
See how the fire is actually directional, using the whole battery.
So yeah, that's all I had for you guys today. I'm gonna make sure to send you guys the checklist for sure, and maybe also get my own kind of, you can say, safety requirements document for you guys to, you know, follow. But yeah, that's all I had. So welcome. We have an exciting journey. And just so that you guys are aware, the ARC, or the Aerospace Robotics Competition, it happens in January. And so we just want to make sure for the next, I think, 4 months to get you guys ready and to give you guys the knowledge and the power to, you can say, for you guys to be successful. And so this year's mission will be search and rescue. I don't know exactly how that's gonna look like yet, but that's what we're told. And yeah, so just be excited. I think that maybe for the month of September, I might show up for maybe every Fridays, and Wednesdays might be Jane's days, right? However, as Jane and I kind of get in sync into what we'll be delivering, then I think I might, like, the more we get closer to the competition, you'll see me take a hands-off approach, just because it'll be, at that point, it'll be your competition, right? So for you guys to run. So awesome. So any last comments? Go ahead, Jane.
I was just going to say, you know, great work, guys. And unless anyone has any last minute comments, we'll see you all. We'll all see some of you for a programming class on Wednesday, and then we'll all meet back here a week from today on Friday.
Awesome.
Sound good, everyone?
Sounds good. So Jane, can you stay on the line really quickly?
I'm sorry, I actually
you have to go.
Yeah, I have another meeting at 5, but I do think that I chatted my email to you.
Okay, awesome.
So yeah, if you email me, we can get in touch and schedule another meeting for this weekend.
Okay.
All right, great. All right, bye everyone. Good to meet you guys.
Bye. I can see your notebooks, by the way.